In an educational institution with a population of more than 20,000, like Universiti Malaysia Sarawak, UNIMAS, checking on compromised passwords is not easy. Furthermore, the availability of hacking tools supported by the worldwide network merged with the culture of staff or students who are not too cautious of password securities has been the contributing factors of this threat. MyTriz is being explored as a way to address network security related real problems in UNIMAS. We found that changing the password is a popular method for mitigating password infringements. However, this method conceives secondary problems to our users. With the engineering contradiction and faulty inventive principle tools, we formulate several solutions to enhance the security of users' passwords without burdening the users to remember complicated passwords. We introduce 4 layers automatic security formation based on simple user password. The partial solution portrayed by MyTriz revealed directions for innovations adopted in UNIMAS. Password authentication is simple, easy to use, low cost, and easy to manage. These characteristics make password usage remains relevant for authentication approach until today and the future. Several authentication methods available in the market, such as biometric authentication and hardware authentication, to name a few, require specific hardware and incur high cost. However, due to the simplicity of password, encryption is the favored method to make it secure and reliable. The biggest challenge in using the password as an authentication method is that users tend to create a simple password for them to remember easily. Moreover, with rapid technology advancement, many applications exist in the organization require users to remember different passwords for various applications. This scenario has forced users to have a simple password, even though they know that securing the password is necessary to prevent attacks, as it is used to access various critical information systems. With the local preferences and reach of resources, we applied MyTriz to find innovations in securing simple password in UNIMAS to help users to access different information systems in a secured environment. In UNIMAS, the academic and administrative staff log into a dedicated computer for attendance check respectively. Somehow, the computer becomes a target by a particular student to get the lecturers' and administrators' passwords. In addition, after the lecture session, some lecturers have forgotten to log out from the system. This mistake allows the student to access the system and install password collector software into the computer. There are several solutions available in the market. However, they are costly and not customized to organizations' needs. UNIMAS, on the other hand, has precious resources such as programmers, network engineers, and IT staff, which enable them to develop their own system to secure their resources. We used cause and effect chain analysis, CITDS tool, to identify the possible root causes of compromised user passwords that occur in UNIMAS. Figure 1 shows the possible answers to the why questions for each branch. Based on Figure 1, we found that the possible root cause are the user awareness of the importance of having a secure password. No severe punishment of hacking to the system has been previously recorded, and too many applications require a password which drives the user to set a simple password to remember. This scenario motivates us to design an environment to have a simple password for users' convenience and meanwhile make it difficult for hackers to guess the password. We are using function analysis to model the password component to further explore what is the information that we can use to achieve our goal, which are simple password and secure. Figure 2 shows the password engineering system that we want to achieve. The password function is to secure the resources from being compromised by unauthorized person. Password entity is the core subject in this analysis. It provides security to the whole system. Therefore, it is necessary to list all the subsystems, supersystems, and objects that interact with the password entity to identify the most vulnerable entity in the engineering system. Figure 3 shows the component of password engineering system. In knowing the component alone is not sufficient to identify the vulnerable entity and the things that can innovate to enhance the ES. Analyzing each interdependent component in the ES gives focus on the creation of an innovative solution. Based on this diagram, hacker and malware are harmful objects to the engineering system. They attack the open resources such as staff registration computers, computers in the lab and the lecture rooms. Besides that, we found that users create a simple password because they want to remember the password easily as they have to access several applications. These scenarios put the resources at risk. As shown in Figure 4, the password interaction analysis, if the password created by user is complex, then it will secure the system, computer, and application. However, this complex password will make it difficult for users to remember and may result in their failure to access the system. This condition is a typical TRIZ contradiction problem, when creating one characteristic will degrade the other. The following is the contradiction statement used in this paper. If complex password is enforced, then the system is secure, but users tend to forget. The improving parameter is strength and worsening parameter is loss of substances. The recommended inventive principles are 35, 28, 31, and 40. This table shows the elaboration of each principle in the quest of finding possible solutions. In recapping, the goal of our ES is to propose a simple password but secure. Many possibilities and ideas to construct a complex password are listed in the previous diagram. Consider the password must be easy to remember by user. We propose a single ID to access all the resources. A single ID eliminates the burden of the user to remember several passwords for different applications. We take the idea from Principle 31, where we break a simple password into a jigsaw puzzle and use one of the pieces to become a challenge question to the user. For example, the password is myPassD32. The system breaks this system into myPassD32 and stores it in different domains or locations. the system will challenge user to key in the last 3 combinations of the password. The system will then randomly generate a question. Therefore, if the student installs software to collect the password, the information obtained does not make any sense to the hackers. Informations are all scrambled. Furthermore, the password is associated with the image stored in the different location. The image retrieved by the system based on the password combination challenges input by the user. Subsequently, if the hacker tries to guess the password combination, the hacker also has to guess which picture belongs to a given password. This scenario allows hackers to think harder in order to crack the simple password that manages a complex system. The system performs all the verification initiated from a simple password. As conclusion, in this project, we have presented the selected CITDS tools to discover several possibilities of constructing simple password but secure. CHECA and FA assist in the identification of harmful objects to the user password. We modeled the problem based on engineering contradiction to discover the recommended CITDS inventive principles. Guided by the selected principle, we proposed 4 layers of security to provide a simple password but secure, applying CITDS concept to find innovations in solutions can significantly improve the system for a sustainable design. And this solution is totally free.